today? Yes, I hope you're doing really well. I'm excited. Yes, it's another math video. What can I say? We're going to be doing some review again, 6th grade review. We're covering this Go Math Module 4, although much of the lessons come from other math programs as well. We will be reviewing the topic of division, and also we're going to have some greatest common factor, maybe some least common multiple in here as well. So anyways, there's about 9 questions, and so we're going to make 2 videos. So look for the second one. Now, let's go ahead and get started with our problem. It says, Isabella, you're famous, is buying hamburger patties and buns for a picnic. Hamburger patties are sold in packs of 4, and buns come in packs of 7. Really, Mr. Wara? Packs of 7? Are you sure you didn't just change the question here a little bit? Because I've never seen hamburger buns come in packs of 7. And you would be right, I've never heard of such a thing. However, it is our problem. What is the least amount of packs of hamburger patties and buns Isabella can buy so that she has an equal amount of both? Okay, yes. Okay, I like this problem. Super easy. Well, because there's a lot of different ways you could solve this. When you really want to show your mathematical thinking, right? We're always trying to show our thinking. This is how we find multiples of numbers. So let's go ahead. To start our list. If we said 4, right, we would just be skip counting. And when you think about it, really all we're doing here is we're multiplying each multiple by another factor, like 4 times 2 gets us to 8. 4 times 3 gets us to 12. So each consecutive number or multiple, we're skip counting, but we're using multiplication. Okay, and we can just keep on going. Now the thing here is that you can see, because 7 times 3 is 21. 7 times 2 is 14. These are just simply called multiples. Now here we get to 28. Of course, we can keep on going. 7 times 5 is 35. Okay, and I just keep on going here. Let me put on another 4 here. 16, 20, and now we have 24. And look at this lucky number here. So look at the least common. Well, the only one we can see so far is the 28. Okay, here we go. What we found was the least common multiple of 4 and 7. Now some of you might have been thinking, but Mr. Wara, couldn't you just take 4 times 7? And that gets you 28 if you take the two numbers and just multiply them. And that's very true. That will get you a common multiple, and it might be the least common multiple too. However, 4 times 7 in this case is it is 28, and it happens to be the least common multiple too. So I'm thinking about the problem, what it's asking me. Now, though we know that 28 was definitely the point where we reached an equal amount of both. But the question says, what is the least amount of packs of hamburger patties and buns? So they want to know how many packs. Well, we can just look at our problem here and see that for the hamburger patties, we had 4, 8, 12, 16, 20, 24 to 28. Well, that was 7 packs. We would need 7 packs of hamburger patties, and we would need 4 packs of hamburger buns. So the least amount then, if we were to add them together, would be 11. Okay, 11 packs, 7. So let me write this into a statement. So I'm going to say Isabella would need to buy 7 packs of hamburger patties and 4 packs of hamburger buns. Okay, I think that pretty much covers the question. And with that information, you can see that the question doesn't ask this, but one of the things that we could say, since there's 28, that Isabella, she could make 28, hamburgers based on that information. Okay? Woohoo! Yeah. Now let's move on to the next problem. Okay, here it says, after a party, there was 3/4 of a julienne pie left. Oh, a julienne pie. Have you ever had a julienne pie? Oh my goodness, they're good. Anyway, it says Jared, you're famous, divided the remaining pie into 5 equal slices. How big were the slices? Use a picture model to support your answer. Well, again, this is a really good question. There's definitely some different ways I'm thinking about how you could solve it. It does say, though, use a picture model to support your answer. So we do need to do that. First thing is it makes sense to me to draw a picture of a pie because, well, it is a julienne pie. Now, I don't have my smart software anymore here, so now I have to do everything by hand, just like you guys. So I'm going to draw everything out. So you see here, it says that there was 3/4 of a julienne pie left. that means that this section here is gone. Okay, so I'm just going to color this in and just know that the shaded part means that already eaten. All right, now that means I have 3/4. Now, if I'm going to take my 3/4, now it does say that Jared divided the remaining pie into 5 equal slices. Well, that would be kind of challenging using this model. Can you see the problems that we're going to have? Because we need to take these 3 pieces here and try to divide it into 5 equal slices. That's going to be really, really difficult. So that's why we kind of want to move on and do an area model. Might be the best way here. So if we draw an area model, what we can do now is we can show our 3/4 again. And I'm going to draw my lines in here. So 3/4 would be this section right here. Maybe he wants to come a little bit over there. Okay, 3/4. So that's 1, 2, 3 pieces of 4 equal pieces. So we have 3/4. And now he's going to divide it into 5. So I think what I'm going to do here is just to kind of show you what kind of happens here. I'm going to write my expression down. 3/4 divided by 5. Now, this expression here, one of the things we talked about was that we could find the inverse operation for this division expression. We could actually represent this as 3/4 times, and since we know that 5 over 1 times 1 over 5, 1 over 5 becomes the reciprocal of 5 over 1 because this gives us a value of just 1. When we multiply across, we get 5 over 5, which is equal to 1. So the reciprocal of 5 would be 1 over 5. So now we could actually make our problem a little bit easier and we'll be able to use our area model. Now we end up with 3/20. So what I'm going to want to do here is I'm going to want to divide this into 5 equal pieces. Okay, not the most equal, but there's my 5 equal pieces. And then what I want to do is I want to shade in 1/5 of that amount. And I see 1/5 going across here, so I'm going to go ahead and I'm just going to crisscross it going this way. So now this whole part, this would represent my 1/5, and this here represents my 3/4. You can see where it crisscrosses, it's this right here. These two, these three right here end up overlapping each other. I use my black here a little bit more clear. And then that is just 3 equal sections then out of my total, which here you can see by just looking at the denominators, lets you know that there are 20 equal squares. So I end up with my 3/20, which is what we just solved here with the algorithm. Now it does say use a picture model to support your answer. Well, I've done that. I've used this is called the area model. And the area models are great when you're multiplying fractions, which is what we did, after we represented our division expression as a multiplication expression. Okay, we found the inverse operation. It's also called the multiplicative inverse. All right, I think that's pretty clear. Okay, here it says an attic has an area of 51 1/3 square feet. The width of the attic is 3.5 feet. Based upon this information, what is the length of the attic? Okay, and I don't see anything here where it's asking me to show my mathematical thinking or my reasoning or my understanding through some type of model so I can solve this problem however I feel is best for me. Well, when I see this, the first thing that stands out without a doubt is obviously a square feet. Okay, square feet suggest square, which I think of area. Well, area has a formula. So I mean, for me, I would always want to put my formula down right away. Kind of helps me understand the problem. Now, area does give us, it says the area is equal to 51 1/3 feet, and I'm not going to put the unit there right now, but that's going to equal, and then it says the length times the width. Well, it says the width of the attic is 3.5 feet, but it doesn't give me the length. So the length I don't have, but I do know that the width is 3.5 feet. Now, that would mean then that if length times width is equal to the area, then I could take the area, which is the 51 1/3, and I should be able to divide that then by the width, which is 3.5. Okay? I say, well, my goodness, Mr. War, how do you do that? We got all these fractions. No worries. We're just going to rewrite our expression. We'll rewrite it here and just put 51 1/3 divided by 3.5. Okay, now we have our expression. In this case, because we're dealing with mixed numbers, we have a whole part and a fraction part. Probably want to convert this first into fractions that are greater than 1 or an improper fraction, because ultimately what we want to get here is we want to get this as a multiplication expression as opposed to this division expression. So 51 times 3 I can see is 153, because 51 50 times 3 is 150, plus 3 more. So 51 times 3 is 153, plus 1 on the top. We end up with 154 over 3. Now we're going to divide that by, again, we're going to change this one, and we're going to have 7 halves, because 3 times 2, and then you add on your 1, you end up with 7 halves. Well, now we can go ahead and get that reciprocal of the divisor, which in this case is going to be 2/7, right? Because we end up flipping these two because it is the inverse. It's doing the opposite. So we're going to go ahead and put 154 divided by 3. Now we can change our sign to times 2 over 7. Now, I always look for opportunities to cancel, to divide out common factors, but I don't see any. I don't know if 154 is a multiple of 7. I don't know if they have that common factor. I don't believe so. So what I'm going to do is I'm going to go ahead and multiply across. I'm going to end up with 154 times 2, which is going to be 8, 10, carry the 1, 2. That's 308. So I end up with 308 over 21. So I need to find out how many times 21 will go into 308. Now let's come over here. See if we can figure this one out. 21 is going to go really nice into 30 just one time. Okay, we end up with 21. We're going to subtract and we end up with 9. We're going to need to regroup on that one there. Bring down my 8. Now 21 going to 98. What, 4 times I think? And that's going to give me what, 8, 4, 84. So look at that. I got 14, looks like, and then with a remainder there of 14. So it's going to definitely go into 308 then 14 times. So let's write that over here. So we're going to have the 14. However, we would have a remainder of 14 over 21. That just so happens this isn't in simplest form because we still have a common factor of 7. So we could rewrite that as 14, 2 over 3 because we have 7 times 3 and 7 times 2. Now, I'm one that always likes to check my work because I don't know if I did. I could have easily made a mistake through doing this algorithm. So I'm going to see about checking my work. What I can do here then is I could just say, well, if I'm saying that my result of the length, and I'm going to put that up here, that I said that my length was equal to 14 and 2/3, then what I could do then is, based on that, if that's my length right here, then that means that 14 and 2/3 times that 3.5 should get me back to 51 and 1/3 because that's my equation. My equation states that 51 and 1/3 is equal to that length times the 3.5 there. So I'm going to go ahead and do that. So my 14 and 2/3 times 3.5. I'm going to go ahead and put this as a fraction greater than 1. 14 times 3 is 42, plus 2 at the top is 44. Okay, I just changed my mixed number into an improper fraction, times my 7 halves. Now what's nice about this here is I can see where I can cancel. I can divide out a 2 and get 1, but I have to also divide this by 2 and get 22. Well, now I just need to multiply across. Well, 22 times 7, let's do that right here. 14, carry the 1, so we have 154. Then 154 over 3. And this may be looking already familiar because we had that one time before. Now we just need to put this as a mixed number. Well, 3 goes into 15, right? 5 times, so we already know that. And because that's really 150, we would actually say that that's 50. Plus that 3 will go into that 4 one more time. That's giving us our 51. And 51 with 1 left over on the top is 51 and 1/3. Now if that seemed confusing what I did, just go ahead and do the long division by putting your 154 and then just divide by 3. And you'll see this is all I did, right? I put my 5, which is 15, and then I brought my 4 down. It goes in there one more time. And then you end up with your 1/3. 51 and 1/3. So it checked out. Oh my goodness, look at that page. Now, based on this information, what is the length of the adduct? We stated that the length is 14 and 2/3. Okay? It didn't ask me. This is me showing my thinking, by the way. I know this isn't a model. It's not a tape diagram or a number line, but this is showing my thinking. Kind of sloppy. I think if I were to do it for my teacher, I'd probably be a little bit neater. Okay? Anyway, there you go. Let's go to the next problem. Okay, it says here, it says AJ ran 3 1/3 miles on Tuesday. You're famous. On Friday, he ran 2 1/4 times farther than Tuesday. How many miles did AJ run in all? Show your thinking. Well, again, we can show our thinking using a model of some kind. We don't have to. So I'm going to just show my thinking through my calculations. But it's important that I understand the problem. So when I think about it, he ran a certain amount on Tuesday, but on Friday he ran 2 1/4 times. That key word there is times farther. It doesn't mean that he ran 2 1/4 miles on Tuesday. That's not what it's saying. It's saying that he ran 2.25 times farther. It's just almost like saying if someone ran 2 miles and I told you I could run 2 times farther, then I'm taking that 2 times their amount. So in this case, then I'm going to want to show my thinking. So I'm going to set this up as 3 then and 1/3 times my 2 1/4. Why? Because it tells me right there it's times farther. So it lets me know I'm multiplying. Okay, now I can't multiply these mixed numbers until I put them as an improper fraction. We've done that before. That's just 3 times 3, and then we add our 1 up here. So I end up with 10/3. Okay, the 9 plus 1. Now that's going to be multiplied with, same thing, just going to take 2 times 4, which is 8, plus 1, which is 9, and I'm going to get 9/4. Now, the nice thing about this here is I can actually cancel because look at 3 and 9 both have a common factor of 3. So if I divide out of 3, I get 1. I divide out of 3 here and I get 3. Over here, I have a common factor of 2. That worked out really nice. 2 divided by 2 is 2. 10 divided by 2 is 5. It makes it easier now, and when I multiply, I don't end up with these huge numbers and then having to divide out the factors later. So 5 times 3 is 15 over 2. Typically, we would probably want to put that back as a mixed number. So I'm going to rewrite that then, is that's going to equal 7.5. And you can see that 7 times 2 is 14 with the 1 left over. Okay, and then with the 2, I just bring it over. That's all I do. So I end up with 7.5. Keep in mind, this is not the answer to our problem because this is a multi-step problem. This just tells us how far AJ ran on Friday. Okay, because we took the amount that he ran on Tuesday, we multiplied it by that 2.25 times farther. So how much farther did he run on Friday than Tuesday? Yeah, well, that's 7.5. 7.5 miles is how much he ended up running on Friday. So now we have to take Tuesday, the day that he ran. He ran that 3 1/3. Now we need to add, because you see the key words up there, right? They say in all. So we're adding Fridays. Now we know that's 7.5. Now we need to add these mixed numbers. Okay, I'm pretty sure we did this in 5th grade. We just need to find that common denominator. And that common denominator that they both have is 6. And a really easy way to do that is just like we've been doing. You do those multiples. And right away when you start your skip counting, as you guys might know it as, now I can see that, okay, I have a least common multiple of 6. So I'm going to use that as my denominator. So I'm going to go ahead and put my 3 1/3. Now I'm going to rename this here as my new fraction. I need to multiply 2. 3 times 2 to get my 6, to get that new denominator. So I'm going to have to multiply that by 2, which means 1/3 is equal to 2/6. There's different ways you can set this up. I'm just writing it this way because this is what seemed to make sense at the time here. And now here I'm going to have to multiply by 3, so you get 3/6. And yeah, 3 is half of 6, so 1/2, that makes sense. So now I have these two new equivalent fractions. Because they have the same denominator, I can add. Remember, when you add and subtract fractions, you need to have that common denominator. All right, that's the rule. With multiplying fractions, we don't have to worry about that. Well, I have the 3 and the 7, so I can add that together and get 10. And then I have my 2, 6, and 3, 6, which is simply 5, 6. So altogether, I end up with 10 and 5, 6. Now I could take my 10 and 5, 6 and subtract and figure that out. But what I'm going to do is I'm going to just do a quick estimate here to see if my answer is reasonable. When I look at 3 1/3, I'm going to say that's about 3. Okay, so I'm just going to estimate. And then here my 7.5 isn't a half, but plus my third, maybe I want to say that's going to make one more whole there. So I'm going to say that, yeah, it's plus 7, but then I'm going to add one more. Okay, because I have my 3 plus 7 is 10, and now when I do it, I end up with 10 plus 1, so my estimate being 11. Well, look how close that is. That is extremely close to 11. In 5, 5, 6, all I would need to do is add on one more 6, and I'd have my full 11. Okay? Woohoo! Yeah! Okay, so let's go ahead and just do one more problem in this video here. We have problem number 5. Look at this. It says, Mr. Torres, you're famous, has 4 4/5 cups of flour. Oh my goodness, he's the baker. Yeah, he makes, what's he making here? It says he plans to make a recipe that uses 2/5 cup of flour. How many recipes can he make before he runs out of flour? Show your thinking. Okay. Well, Mr. Torres is the baker. Yay. Hope he's got some nice blueberry muffins for us for a change. Yes. Okay. Anyway, get serious, Mr. War. Okay, I shall try. All right. So we have here just what does the problem say? It's just that Mr. Torres, he has a certain amount of flour. He's got a big container of flour. Okay. And he wants to make a recipe that uses some of that flour that he has. And we want to know how many recipes, almost like how many groups of each one of those recipes or batches can he make before he's going to run out of all that flour that he has. Okay, so that's just what the word problem says. Now we start looking at the math, we can start to see that yes, we have 4 and 4/5 cups of flour. So he's got almost 5 cups of flour. And he's taking this recipe that uses 2/5 cup, which is pretty small, almost half a cup, not quite. If we had 2.5, 2.5, that would be half of 5, so that would be half a cup of flour. We need to figure out how many recipes he can make. Well, this throws out when I keep repeating that to myself, and you might be wondering, gee, Mr. War, you're really talking to yourself. Yes, I am, I know. And part of the reason is when I verbalize that, when I say that out loud, it helps me understand what the problem is asking me to do and what operation I will need to use. And I can see that division is what I need. Since it just says show your thinking, I don't have to do an area model, I don't have to do a tape diagram, so I can just kind of show my thinking, and my calculations are going to be that. So I'm going to first write my expression in 4 and 4/5, and I'm dividing that by that 2/5. And why am I doing that? Because remember, I want to find out how many 2/5 are there in 4 and 4/5. Now, because these numbers are so high, not that you couldn't do a tape diagram, I'm just going to use the standard algorithm. First thing I want to do is I want to change my mixed numbers into improper fractions, or we also say fractions greater than 1. So I'm just going to take my 4 times 5, which is 20, and then I'm going to add my 4. Right away, I get 24 over 5. Now I'm going to divide that by 2/5. And now I get in that form that I can handle. This is a division expression. It'd be really nice if I could find the multiplicative inverse, or just the inverse operation. 2/5 times 5 over 2 is equal to 1. That's how I know that I have the reciprocal, and this is what I need, of 2/5. So I'm going to rewrite my expression then, 24/5 times 5 over 2. Now I've changed the sign, okay, and I've flipped my divisor. Remember, I use these words a lot because it's important that we can identify the terms of the numbers in an equation, and that is called the divisor. So we found the reciprocal of the divisor, which was 5/2. Now, the neat thing about this is I can start dividing out some common factors. We look at this 5, these cancel. That leaves me with just 1 here. This is nice because 24 is a multiple of 2. They both share a common factor of 2. So if I divide out a 2, I get 1 here, and here I get 12. You're kidding. It's over? Yeah, because when we multiply, we just multiply across. I have to put 12 over 1, just so you know. But that's the same as just 12. Is that possible? Did it work out perfectly? 12 recipes? Now, if I were to write my statement, Mr. Torres can make 12 recipes. I almost kind of think of recipes as just like one, how many recipes, like batches almost, you know? I don't know. Maybe that's how the bakers talk. Let's ask Mr. Torres. He would know. Yeah, I mean, I'm not much of a cook or a baker myself. Anyway, so Mr. Torres can make 12 recipes with 4 and 4/5 cups of flour. And I'm just adding that in. I don't have to write that in there, but just letting you know this was all the flour that he had. We could always check our work again, right? Yes, we could. We should probably do that, because if we're saying that 4 and 4/5 divided by 2/5, because that was our initial expression, is equal to 12, then 12 times, right? We're going back in reverse. 2/5 should equal 4/5. This is nice and easy, isn't it? 12 times 2? Yeah, 24. That would 24 over 5. That's quick. Now we can write this as a mixed number to see, does it look like what we said it was supposed to be? Well, 5 goes into 24 4 times, doesn't it? Because 5 times 4 is 20. I can't do 5 times 5, 25, because that's too large. I end up with 4 left over. And with my 5, bring it over. And there it is. And what do you know? Woohoo! Yeah. That's right, my friends. Look at that. 4 and 4/5. Oh, I'm telling you, I'm loving it. Woo! And do I hear that music? Yes, I do. it is the end, my friends. Oh my goodness, this was just way too much fun. You know, when I was a kid, we'd say, this was more fun than a barrel of monkeys. Yeah, and if you don't know what I'm talking about, I guess you'll have to Google that to see what a barrel of monkeys is. It was a really fun toy. You know, pre-video games. That's right, Mr. Warsaw, old. Yes, I'm from a time before the TV. No, anyways, I'm pretty old. Now, my friends, review number 2 will be coming up for Module 4. Now, live long and prosper.